Okay, the last class we have discussed with regard to designing the finite automata uh, for a language of A's and B's in alphabets, right? So where number of A's will be divisible by 2 and number of B's divisible by 2, right? So here what is number of A's in the sense in the word we are counting the number of A's, mod 2 divisible by 2 in the sense the remainder is 0. So here the mod operator gives you the remainder. The number of A's in that word mod 2 is equal to 0. Number of B's in the word mod 2 is equal to 0. So for that condition, we have to design the finite automata. First, we have designed the finite automata for this one, so this, and finite automata for B divisible by 2, number of B's divisible by 2, and this is here. Right now, what we are going to try to do is we are going to proceed with integrating, that is and condition. So the number of A's and B's in the word should be divisible by 2. Okay, so how we are going to proceed with that? That is what we started with in the last class. So here, how many states are there? 2 states. So here we are going to take the cross product of these two. We are going to take the cross product of these two. So here, how many states? 2 states. Here, how many states? 2 states. So here in the final DFA, I'll be having 2 cross 2, that is 4 states will be there. So, okay. So here, what are the 4 states? It is going to be the combination. So here, Q0 cross Q2. So that is Q0 Q2, right? And next is Q0 Q3. Yes. Q1 Q2. Yes. Right. Q1 Q3. Yes. Right. Are you clear with how we are assigning? So here in this case, you should not go for a new name. So we can proceed further only if we are giving the name based upon the previous DFAs, existing DFAs, right? So from these two DFAs, we are proceeding with constructing a new DFA. So we have to take a cross product of these two DFAs. So the names should be dependent upon these two. Okay, yes. So now what is the next target is we have to identify the start state and the final state. So how to identify the start state and the final state? So what here in these two DFAs, which are the final states, Q0 and Q2 are the final state. So here among these four, so a combination of Q0 and Q2 comes here, right? So this will be designated as the final state. And next comes the start state. Yes, again, which is the start state? Q0 and Q2 is the start state. So this node will act as the start state. So next we have to proceed with giving the transition. All right. So here you can see on from Q0 on input symbol A, I am having transition to Q1, right? On input symbol A, I'm having transition to Q1. So same thing I'm having. So here there is Q0, here there is Q1, right? So on input symbol A, I'm having transition to Q1. And similarly on input symbol, so here again, next is, yes, let me proceed with this transition, right? So from Q1 on input symbol A, I'm having transition to Q0. From input symbol, for input symbol A, I'm having transition from Q1 to Q0, right? Q1 to Q0, right? Okay, so here next comes, yes, similarly, the same thing here. Here, I'm having Q0 to Q1 transition on input symbol A. Similarly, here also I'm having Q0 to Q1. So this is for input symbol A. Again, Q1 to Q0 for input symbol A, there is a transition. So again, I have to proceed with giving the transition from Q1 to Q0, right? And next comes for input symbol B. For Q0, I am having transition to Q0 itself. For input symbol B, I'm having transition to Q0 itself. Okay, so I'm giving the transition from right. Yes, similarly here, yes, you can see from Q1, I'm having transition from on input symbol B, I'm having transition to Q1. Okay. Okay, so the next we can check it with here. So here you can see, so on input symbol B from Q2 to Q3, I am having a transition. So from Q2 to Q3, I'm having a transition. Yes, from Q2 to Q3. Yes, here you can see, right? From Q2 to Q3, I'm having a transition, and from Q3 to Q2, I should have a transition, right? From Q3 to Q2, I should have a transition on input symbol B. So here again you can see, right, from Q0 to Q0 I am having transition on input symbol B. So here this transition we are given. So this transition is included here. This Q0 to Q0, yes, I am having transition. Similarly here Q3 to Q2 I am having a transition on input symbol B. Alright. And next comes yes. So this is for input symbol B, right? Yes. Yes, we can check it with this one. Yes, right. For input symbol B, I'm having transition from Q2 to Q3. Yes, it is already given. Yes, now it is Q3 to Q2. Q3 to Q2. Input symbol B. So now we can even check for A. So for input symbol QA, I'm having transition from Q2 to Q2. Yes, is that here? Yes, Q2 to Q2. Yes, there is transition. Similarly, Q2 to Q2, there is transition. So here you can see Q3 to Q3 on input symbol A transition. Q3 to Q3. Here Q3, here Q3. Yes, there is transition. Similarly, here Q3, here Q3, there is transition. Okay. Is that clear for you all?
Yes.
Yes. Okay. So now what you're going to try now is proceed with designing a finite automata. Okay. So where number of A's are divisible by number of A's are divisible by 2, and number of B's are divisible by 3. Divisible by 3. Okay. You are going to design the finite automata for this particular condition. Okay. Please do try it out now. First, what we have to do, first we have to design the DFA for this one, and then we have to design the DFA. That is, it is nothing but n of A, number of A's in the word mod 2 should be 0, right? For that, we have to construct the DFA, and number of B's in the word mod 3 is equal to 0, right? So for that, we have to first design the DFA, and then we have to proceed with finding the cross product of these two DFA. Okay, first we proceed with that. So n of A, that is number of A's in the word mod 2 is going to be the same one already we have discussed with, right? So that is Q naught Q1 and A. So only if there are multiples of 2, number of A's are multiples of 2, then it will be accepted, right? So I can have any number of B's. This is for this one, right? And then if it is going to be mod 3, this is Q2. So here I'm going to concentrate only on the number of B's. Okay. So here we are having here there are 2 states. Here there are 3 states, right? So for, if I take the cross product of these two, how many states will be there in my final DFA? Yes.
6.
Yes. So here 2, 3. So 2 cross 3 is equal to 6 states. So what are the states will be there? So it is nothing but so Q0, Q2, Q0, Q2. Yes. Next is Q0, Q3. Next is Q0, Q4. Here Q1, Q2. Likewise, it goes on, right? So now try proceeding with. Have you all completed? Have you completed the DFA designing?
And the final one or the other two?
This one, final one.
I'm still doing that.
Okay, okay, proceed. Okay. So here we have to find out the final states. So you can follow the previous example, right? They completed. Okay. Okay. So here we can start with, hope you, most of you would have completed, right? So here, yes, this is Q naught, this is Q2, right? Okay. Here we are going to take the cross product of these two. So which is the final state and which is the start state here? So Q naught is final state of this DFA and Q2 is the final state of this DFA. So the states with the combination of these two will act as the final state, right? So this will be acting as the final state. And similarly, start state, this is start state and this is start state. So this will be acting as the start state. Next comes the transition. Yes. So here in this case, from Q0 to Q1, I'm having the transition on input symbol A. Q0 to Q1, I'm having transition on input symbol A. And similarly, Q1 to Q0, I'm having transition on input symbol A. So yes, similarly for all the cases. Okay. So the next is Q2 to Q2. Q2 to Q. Yes. Yes, that is already there. So next we can move on with the transitions on B. Q0 to Q0, there is transition on input symbol B. So Q0 to Q0, there is a transition on input symbol B. Next again, Q0 to Q0, there is a transition on input symbol B. Similarly, here Q1 to Q1, there is transition on input symbol B. Here Q1 to Q1, there is transition on input symbol B. So here we can see, so yeah, we can check the scenario over here, right? So both should be mapping. So for both, so that for the transitions, the sorry, for both the DFAs, the transition should be mapped, right? So the next is, here we can see Q2 to Q3. Yes, there is a transition. Q2 to Q3, there is a transition. Q3 to Q4, yes, there is a transition. Next, Q4 to Q2, there is a transition, right? So Q4 to Q2, there is a transition. Similarly, Q4 to Q2, there is a transition on input symbol B. So here we can see, so if there is, for example, if it is A, B, 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 right? A, B, B, B. So you will, this is a valid string, right? So here we can check. So please make a note how we can proceed with finding the, proceed whether the string is valid or not by means of the transition function, that is delta, right? So for delta, which is my input symbol, A is my input symbol. What is the start state? Q0. Okay, so Q0 is the start state and what is the input symbol? A. So where will be my transition? So I am in state. Okay, okay, this will not suit good for now. There are two combinations. Okay, so here we can have. So here I am in state. Here I am in state Q0, Q2. So on coming an input symbol, so where is my transition? Q1, Q2. So here I'll be Q1, Q2. So here again I'm coming across here. Where will be my transition? Q0, Q2. Q0, Q2. On input symbol V, I'll be having a transition to Q0, Q3. On input symbol V, I'll be having a transition to Q0, Q4. On input symbol V, where will be my transition? I'll be having a transition to Q0, Q2, which is a final state, right? So I started with the start state and I ended with the final state for the entire word. Are you clear with this?
Yes.
Yes. Okay. Now what you are going to do now is I am going to give you some practice questions. Please do work it out. Okay. So here, yes, take down the questions. Here the input alphabets are 0 and 1. Okay. Input alphabets are 0 and 1. 0 and 1. You have to design the finite automata which accepts the language that have 3 consecutive ones. Okay, that accepts should have 3 consecutive zeros. Okay, should have 3 consecutive zeros. So please make a note. You are going to design the automata which accepts the language strings of language that have 3 consecutive zeros. Okay, so all the strings in that language will have 3 consecutive zeros. Okay, so this is going to be question number 1. So this is question number 1. The next is does not contain consecutive ones. Okay, so the first question is 3 consecutive zeros should be there in the string. The second question is the finite automata should accept only if the string does not contain consecutive ones. Okay, I can have 101. 110 is not possible. Okay, I can have any number of ones and any number of zeros. The only thing is that consecutive ones should not be there. So number of ones we are not restricting. So consecutive ones we are restricting. Okay. So here in this case, we are talking of 3 consecutive ones, 0 should be there. Okay. So this is with respect to, so here for both the cases, the input alphabet is 0 and 1. Okay. The next is starting with, this is simple one, starting with the 0 and ending with 1. Okay, starting with the 0 and ending with 1. Okay, so please do work it out now. Please work it out. I'll be sharing you the questions in the chat box.